Trina Ray, what's your official title, just for the record, please?
Currently, I am the investigation scientist for the ice-penetrating radar instrument on Europa, and I am the deputy science manager for the Europa Clipper mission, and I'm also a principal at the laboratory in science operations.
Okay, a basic question. Why do we need to know if there's water under the ice on Europa? Why is that important?
Oh my gosh. So water is one of these things in the solar system that when we follow the water, we learn all kinds of things. There's just all kinds of potential for habitability. If you have water everywhere on the Earth where we have water, even if in the depths of the ocean where it's super hot, like at those vents, if we have water, if we have chemicals, if we have energy, we have life. And so there's a potential for habitability on Europa that is very intriguing.
Outstanding.
John Tessler with geekykool.com.
Hi, John.
What got you interested in working for NASA?
This, Star Trek, Star Wars, science fiction. So voracious reader when I was young. Followed, Star Wars and Star Trek are sort of my first memories of engaging with pop culture. Lindsay Wagner with Bionic Woman, Linda Carter for the Wonder Woman television show. Absolutely influential. So science fiction was my gateway drug.
And especially with Star, there's so much science fiction that now has become science fact. Is there anything from when you were growing up that you're like, read in your sci-fi that you're like, oh, this is real now? Like, do you have like a favorite thing?
It's kind of cliche, but it's the flip phones from Star Trek, right? Like, I always thought that was really amazing.
Video conferencing.
Video conferencing, but
all started there.
Like the flip phones are something that I remember thinking that, that just seemed, because the wires at that, when I grew up, I just thought, how could you get away from that? And so, I know it's a cliche answer, but it's really the flip phone from Star Trek.
I have so many questions. I'm trying to figure out where to go. So you're on when the probe that crashed into Saturn. It did that to eliminate and reduce the radioactive possibility of the matter going into space.
So actually, not quite. So Cassini-Huygens went to the Saturn system and had an incredible run. I was on that mission for decades. But there were two moons that really caught our attention. The Titan, which has just incredibly complex chemistry.
Enough to be a planet.
It is big enough to be a planet. It has a thick atmosphere, right? Of all the atmospheres in the solar system, there's sort of Venus, Titan, Earth, Mars. And it's incredibly complex chemically. So there was Planetary Protection is a group. It's an international group, and they give rules and regulations. And one of them is you have to clean spacecraft before it leaves, all kinds of stuff.
That sounds very Star Trek.
Yeah,
it really does.
And by the way, if you ever want to go back like a few years ago, they advertised for the head of Planetary Protection. Just that ad for that job was spectacular, by the way. But anyway, Titan, very interesting biologically, especially to the astrobiology community, and also Enceladus with its plumes connected straight to its ocean. So, there were rules. You cannot crash into Enceladus or Titan. You have to dispose of the spacecraft, which clearly will have some Earth bugs on it, or not bugs, some Earth biological biological matter on it. No matter how hard you clean the spacecraft, you can't get rid of it all. So you have to dispose of the spacecraft some other way. And we chose to dispose of the spacecraft by crashing into Saturn after these incredible orbits where we plunged in between the planet and the rings. Very exciting. And so it wasn't the radiation or anything like that. It was the biological matter on the spacecraft. And also it was a rich scientific opportunity on the way to disposing of the spacecraft.
Some interesting views on the way down.
Yeah. It was, and all 22 of those orbits were incredible. First of all, you'd never put the spacecraft, we never designed the spacecraft for that. We literally had flight rules that says outside of 2.4 Saturn radius, because that's the radius of the rings, this is the rule. Because nobody was like, well, you'll never get inside of 2.4 Saturn radius, the rings are there. So literally every piece of our mission, all the processes, all the people, the spacecraft itself had to do things it was never built or intended to do. And it was all in service of this glorious end of mission opportunity. And it was incredible. And like you said, the very last bit of data, we couldn't quite reprogram the spacecraft, but we had to sequence it so that the ion and neutral mass spectrometer would fill up. So normally all the instruments are filling up the bin, and when the bin fills up, then it goes out the horn, right? To this. But we changed it so that every time the mass spectrometer put a packet in, all the other instruments put exactly the right information in so that that packet would go out. So ion neutral mass spectrometer, boom, out to the horn, out to the earth, so that the last piece of information was a sample of Saturn's atmosphere. You should be having goosebumps right now. Do you have a goosebump? I have goosebumps. And it's been 5 years, right? So, as crazy awesome. Yeah, John.
So you get back all this data from Cassini Huygens. How long does it take the scientists from NASA to look at all this data and extrapolate it all out? Are you still working on it?
100%. There will be PhDs there will be young scientists who get their PhDs on Cassini data for decades. So there's the data that you get right away. Sometimes it's the images, the low-hanging fruit. Those get published very quickly. Then there's the sort of the easy data to be done, and then there's the data that's hard, that you need to sort of the full 13 years of the mission, trying to understand something. It takes time, but it was a incredibly rich data set for the Cassini mission, and we will be data mining it for decades.
You mentioned the mission was 13 years. How difficult is it that when it takes so long to get somewhere, how the technology has changed in the meantime once that's left the world? When we're you send out Apple ones and we're on like Apple 20s or whatever by the time the mission actually starts.
So you just have to embrace it, right? It is what it is. It will be what it will be, right? NASA has a lot of policies that drive, especially a flagship mission, to be low risk. And so they invest money in flagship missions to drive down risk. And that means you have to step your technology backward. You can't take big step forwards in technology. On smaller missions, or if you have what is called a technology demonstration, you can take a risk. Like, for example, the Ingenuity helicopter on Mars 2020, that was a technology demonstration. If it had completely failed, it would have been, that we learned that was the purpose of it. But of course, it was spectacularly successful. So it's just the way it is. And it hurts. And outer planets are the worst because it takes 7 years to get there. So on top of the 7 years it took you to get there, it's the 4 years of building, but then the 3 years before that is where you had to get all the approvals. So it's technology that is, by the end of the Cassini mission, it was technology that is, 15, 20 years old.
Y'all just keep like old systems around just to...
we actually did that on Cassini on the ground system. Towards the end of the mission, it wasn't worth it to pay the money to upgrade the ground system. So we actually went out, I'm pretty sure they went out on eBay, but I'm not 100% sure about that. But they got these old Sun Microsystems Spark stations, and they were just like, okay, let's just have a pile in the corner, and when we need to repair them, we'll just go to that pile, and that's how we'll keep our ground system going.
So when the satellite crashed into one of the planets, did it cause any damage to the planet or the satellite?
So it definitely caused damage to the satellite.
Hopefully.
So the planet is big, and the satellite was going in at about 35,000 miles an hour. So basically, within about 1 minute, the satellite went from I'm fine and I'm talking to the Earth, all of its bits got ripped apart, and then they started to melt, and it was destroyed in about 1 minute. But I like to think of it as it has become part of the planet that it studied for 13 years. So that's how I choose to think about it.
It went around Saturn 23 times, you said?
The last 22 missions were these plunge missions. Overall, it went around 250, 260 times. I don't remember
A
anymore.
plunge mission, it would go into the atmosphere
So
and
yeah,
get more stuff.
It was never designed to be a probe, so it plunged in between the planet and the rings, and on the very last one, it flew by Titan and diverted the probe, and it went into Saturn.
Wow.
So when it went into Saturn about 35,000 miles an hour. And by the way, this is one of the first interviews that I've had in 5 years where I haven't cried when I've talked about Cassini ending. So, we process and we get over it at some point. Not get over it. We are able to have an interview without crying.
So one time you actually lost signal of the satellite.
Yeah, no, right then. We told the spacecraft, point to Earth and tell us keep pointing at Earth as long as you possibly can, and tell us this ion and neutral mass spectrometer data.
So you programmed it?
We did, and we told it to do that, and it tried. It tried really hard. You could see its thrusters firing. Oh, I'm fine, and then pretty soon its thrusters were firing at full, trying to keep the spacecraft pointed, and then it got.
But since there's no gravity in Earth,
No, there's gravity at Saturn, yeah.
Oh, there is on Saturn.
Absolutely, there's gravity. There's gravity everywhere, but especially when you're close to a planet, there's gravity. In fact, it was the gravity of Titan that allowed us to change the trajectory to crash the planet, the
but then
spacecraft.
how did it crash on Saturn?
It just went, it's a big gas planet, so it just went into the atmosphere really, really, really fast. And because the atmosphere is hot enough, it rips it apart.
If I can just toss. Gas planet.
Yes.
Is there a solid thing? Or it's gas?
Yeah, so
'Cause
it's...
For kids
right.
in middle school, that's confusing. Even
Yeah,
for
so
me.
it's a gas planet, but as you get closer to the center, the gas gets hotter and thicker and more dense, and then right at the center there's a solid, but it's very, very deep.
So there's a little solid ball with a bunch of gas.
But the gas gets so it's solid, then there's liquid gas, and then there's gas, but it's huge gas, and then liquid gas, and then solid. It's crazy. Yeah.
What advice would you give middle school, high school students that want to get into working with NASA or one of the other civilian space companies that have popped up?
So the advice that I would give to middle school is study hard. It's a competitive field, and you have to work hard at it. You don't have to be the most brilliant at it, right? You don't have to be a genius. You have to work hard. The geniuses don't have to work very hard because they're good at it. Those of us who are not at genius level, we have to work harder. So study hard. Find out if you really like it. So when you're in college, go ahead and do internships with NASA or with other private companies because you might not like it. You might think you like it, but you might not. And then the other thing is that there are a lot of opportunities. It's not just NASA, it's not just SpaceX. There's a lot of places out there, Lockheed Martin. There's a lot of companies that are adjacent to NASA and provide services to them. And so it's not just working at a NASA center, but internships and study hard. Those are the keys.
So what's the Clipper mission? What's the current? We've talked about Cassini. What's like the current thing you're working on?
Yes, Clipper mission is in a very exciting time right now. We are in the building of the spacecraft. So all the pieces have come together, almost all the pieces, and they are delivering. I think this is our last one. All the pieces have come together and we're delivering. There's a camera in the high bay, and you can watch it being built 24/7. It's called Clipper Cam, and you can watch it being built 24/7. So we are in the integration phase and testing phase. And just last week, they did their first test with all the instruments on and pretending that it was a flyby. They pretended it was E18, the 18th flyby of Europa, and all the instruments went on and they did a whole test. And so I was on a plane flying into Atlanta. I landed and all my friends were like, do you want to go? And I'm like, no, I want to go to the hotel. I'm going to go to the hotel and I'm going to log in and I want to watch this test. And it went fine, right? First time all the instruments on, all the instruments operating as if it was a flyby. So we are building and testing at JPL. We will leave for the Cape around May of next year. We'll launch, our launch window opens on October 10th of next year. It'll take us about 5 or 6 years to get out to the Jupiter system. And so we'll go in, we'll do a couple of Ganymede flybys to shrink the orbit, and then we'll start doing Europa flybys every 21 days.
That's
so,
awesome.
Yes. All right, I got the sign from Tillman that we're absolutely.
Have any social medias you want to tell people to follow?
Trina at JPL is the only one that I have, and it's the Twitter. Well, I guess it's not Twitter anymore, but I don't do a ton of social media, so.
Trina Ray, what's your official title, just for the record, please?
Currently, I am the